now what I'll do is I'll define load image function, which we'll be using to load the image. When we click on the button, this function will trigger and we'll be able to load the image. So I'll simply define load image, and this image will basically take the file path. Okay, so in this case, not the path, but the binary file, which is actually loaded from your file location. So let's say uploaded file, okay, is the binary file which we'll be using. And then I will also specify the image size, and I'll make sure that this image size is basically a default parameter, because in some cases, if I do not mention, or let's say forget to mention the size, so size can be taken by default. Okay, so let's say the default size for my image is 256, 256. It is not, again, guys, it is not necessary. You can take it anything, but I want to keep the balance. If I decrease the size too much, the image will be quite janky, it will not be very clear. And if I increase the size too much, it will basically be useless, because our whole application will become heavy. Okay, so it's always a good option to keep things in the middle. And now if I, let's say, travel back to the page, you can see that there are in reality 2 different columns. So this whole thing is one column, and this whole thing is a separate column. Okay, so now we have to specify that from which column you are loading the image. So what I'll do is I'll specify a column as well here. I'll simply write column is equal to, let's say by default it is st. Okay, st means my streamlet. Okay, and if I pass something, it will then take the column name. Okay, whatever I pass, but by default it is st. Now let's load the image. Okay, so guys, remember that I already have the binary file. Okay, I just have to somehow convert it into an array and then use it. Okay, for my calls. So what I'll do is I will write image is equal to image which I imported from pil.open. Okay, and then I'll simply pass the uploaded file there. Okay, and I'll go to the next line and I'll try to convert this img, which is currently an image object, into a tensor, or you can say into a multi-dimensional array. And to do that, I can simply write img is equal to tf dot convert to tensor. Okay, and I'll pass this img here. So I had an image which was basically an image object. Now it is converted into a multi-dimensional array, or you can say a tensor. Okay, and then I'll simply proceed. Okay, there is one more very common actually problem with most of the CNN models, or I would say, yeah, CNN models. That is that the dimensions, let's say if you try to pass an image which has like odd dimensions, for example, which is not a perfect square, then you may face some issues, especially in case of these generative models. So what I'll do is I will try to crop my image. Okay, I'll try to crop my image into a square size, and for that let's just name that function crop center for now, and we'll create the function later. So what this function is meant to do is that, sorry, img is equal to crop underscore function. Let's say cross image will be much more better option. So it will take the image, it will crop it, and it will return the image to me again, right? So we'll create the function later. For now, just assume that we already have this function which has this functionality, right? Okay, now let's proceed further. So we have the image, okay, which is in a tensor format, and we basically converted the image into a square as well. Now let's proceed and see that if I need to resize my image or not. For example, if I pass the size here, okay, in that case I might need to resize my image. So in that case, I'll simply write img again is equal to a TensorFlow, because guys, see why I'm using TensorFlow is because my image is currently a tensor, or to be more accurate, it is currently a tensor object from TensorFlow. So I'll simply write tf dot image dot resize. Okay, and then I'll simply pass my image, which is img in this case, and I will also pass my image size. So here we go, image size, and my image is resized as well. Okay, because in some cases we might need it. So basically we prepared in advance. Now I already have all the things. Now, guys, there is one more problem which you might face in some cases, especially in case of PNG images when the background is missing. Okay, when the image is transparent. What usually happens is that you have a three-framed image, red, green, and blue frame image. Okay, basically there are three frames, but in some special cases there are four frames in the image. Okay, so in those cases we might need to fix that. Okay, so like if you are sure that you will not be using any of such image to take the style and convert it, then it's totally fine. You can proceed by this assuming that every image will be three-dimensional. But if in some cases you're thinking that your image might be having four frames, in that case you need to convert it. So if my image has four frames, what I'll do is I'll pick the first three frames. Okay, and for that I'll simply write an if condition. If I will simply either I can take the shape or I can go for the length. I'll simply go for the shape. So img dot shape, and shape minus one, okay, is equal to 4. In that case, I'll simply write img is equal to img, and because it is a tensor, so I can do the simple slicing with it. So colon, comma, colon, comma, uh, colon 3. So I'm basically picking the first three frames out of the four frames in my image, in case if my image has four frames. Okay, it is not sure that your image will be having four frames, but in case it has, then I will simply treat it. Okay, so now let's just go ahead and try to reshape our image, because guys, the model which we are using is it basically expects you can say a bunch of images. So even if you are passing a single input, or you can say a single image to the model, it is actually required that your input looks like you can say an array of multiple like images, where the array contains only a single input. So I'll simply resize my image, okay, to make it look like that. So I'll simply write img is equal to, again, I'll go for tf for TensorFlow. So tf dot reshape, and here I will pass img again, okay, and then I'll simply pass the shape I want. So as I said, I don't actually care how many images I have, so I don't care about the fourth dimension. So I'll mention one minus one, and then I'll mention the size of my image. Okay, so I don't want to change the size. Okay, I'll simply like mention image size at 0. Okay, and then I'll simply put a comma and write image size at 1. Okay, there. And then because my image by now has 3 frames, I'll simply mention 3 here. And then there is one more thing I'll do. I'll basically normalize my image. This is a normal convention which we perform with almost every CNN model we make, like ever. Okay, it is to make sure that your training doesn't get very heavy, or in some cases your weights do not explode. So I'll simply divide the whole thing, because guys, there is one more fact I will tell you if you are not familiar with it, that in each image, each pixel actually has a range of values, which varies from 0 to 255. And these values actually represent the intensity. So what I'll do is I'll simply divide the whole thing by 255. Okay, so if my image has 0 as intensity at a particular pixel, it will not be affected. 0 by 255, sorry. Um, Sorry about that. 0 by 255 will basically be 0. But if my image has like value close to 255, like 200 or 255, in that case, it will basically be normalized between 0 and 1. Okay, so I'm converting all my pixel values from 0 to 255 to 0 to 1. Okay, so now I have everything prepared. Okay, I have my final image. And what I'll do now is I'll simply display my image as well. Okay, so I'll simply write col. Col is basically my column from which I'm calling the image. I'm basically loading the image. I'll write col dot, or you can say column dot image. Okay, and I'll pass my current image. Okay, but there is one more problem in some scenarios that this Streamlit actually does not accept the TensorFlow object. Okay, so what I'll do is I'll simply convert my TensorFlow object into a NumPy array. Okay, and I'll pass my image here. So I'm basically displaying my image as an umpire now. Okay. So when I call this load function, this load function will basically load the image, okay, do all the required processings on it, for example, resizing, reshaping, normalization, and it will basically display the image as well at the end, right?